Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at the parametric definition of a circle. So in previous videos we've shown that the equation x squared plus y squared equals 1 traces out a circle in the Cartesian plane, and more generally x minus a squared plus y minus b squared equals r squared traces out a circle with centre AB and radius r. But today we're going to look at a different way of defining it, which is x equals cos t and y equals sine t together. So they're both expressed in terms of a parameter t, which goes from 0 to 2 pi. And that traces out a circle. And one way to understand that is to see that cos squared t plus sine squared t equals 1. So that's a standard trig identity, which shows you that whatever the value of t is, the point is exactly 1 unit from the origin. And that's exactly what a circle is, isn't it? I mean, we can imagine creating a circle by getting a piece of string that's 1 unit long, then pinning one end to the origin and then putting a pencil on the other end and just spinning it around the origin. So it's all the points that are 1 unit from the origin. Looks like this. Obviously these aren't all the points, they're just a subset. And this diagram kind of brings it to life a bit more. So here's the kind of hypotenuse, which is length 1, and then here's t, which is this angle. So you've got cos t here, which is the x value, and sine t there, which is the y value. And there is a more general form, so that's kind of a circle with radius 1, centre at the origin. But if we want to move it around, we can say x equals r cos t plus a, y equals r sine t plus b. So the plus a will move the centre to the right by a units, and then the plus b will move the centre up by b units, and then r will just make the circle bigger. So this is the general formulation, which kind of matches x minus a squared plus y minus b squared equals r squared. In fact, if we were going to be really brave, and let's be brave, if we substituted in x cos t plus a and y equals r sine t plus b into this, then what we'd get is the a would cancel, so we'd get r cos t here, the b would cancel off, so we get r sine t here, and then that's squared, so you get r squared equals r squared, so it satisfies it. So it shows they're really the same equation, they're tracing out the same curves. Okay, so here's another example. So here what we've done is we've just said, so we've kept the radius as 1, but we said cos t for x, and then y equals sine t plus 2, which has moved the centre up by 2. Here's one in which we've moved the radius to 2, so this is x equals 2 cos t and y equals 2 sine t. Looks like this. Beautiful stuff. On this one, we started to get a bit creative. We've only multiplied the x coordinate by 2, not the y coordinate, so instead of a circle, we've got an ellipse. So this is the parametric method, doing all sorts of interesting new things. And guess what we trace if we go x equals t cos t and y equals t sine t? Looks like this. Oh, so beautiful. So what's happening here is, in a sense, as we go round and round, the radius is getting bigger and bigger and bigger, so it's spinning out into a spiral. So there's all sorts of creative and beautiful shapes that you can make with this parametric method, which wouldn't be possible, or wouldn't certainly be as easy with other kind of ways of representing. I hope you like this video. If you do, please hit the like button. You're very welcome to subscribe and hit the notification bell. I'd love to hear your ideas, and most of all, I very much hope you enjoy your mathematics.